There's something off about our universe, something fundamentally wrong written into the very fabric of space-time. And you can only really see it when you look at the oldest light there is. It's a cosmic cold case. And the prime suspect? Well, it might just change everything we think we know.
So, our whole investigation, it really kicks off with this one question. Because when we look all the way back to the dawn of time, we find this, a giant bruise on our universe, a cold spot where there just shouldn't be one. What in the world could have left a mark like that?
All right, so here's our game plan. First, we're going to examine the scene of the crime, this glitch in the cosmos. Then we'll bring in our three main suspects: a universe built on a kind of crystal code, another born from a massive cosmic collision, and a third where reality is just one single particle. We'll put them all on trial and then see what this whole investigation tells us about the true shape of reality.
Okay, first up, let's look at this glitch, the cold spot. To get it, you have to look at the universe's very first baby picture. It's called the cosmic microwave background, and it's basically the afterglow from the Big Bang. Now, for the most part, it is almost perfectly uniform. But there's this one area, a region that's 1.8 billion light years across, that is just way, way colder than it has any right to be. And that's our anomaly.
And this chart, this really shows you the scale of the mystery we're dealing with. Our best guess right now is that the cold spot is something called a supervoid, basically a huge empty patch of space. But as you can see, that idea only explains about 20% of the coldness. The other 80%? It's a complete and total anomaly. Standard physics has no answer for it. So it's time to bring in our first suspect. So our first suspect comes from a pretty radical idea. It asks a wild question. What if reality isn't smooth? What if, at the most fundamental level, it actually has a rigid geometric structure? And that brings us to the crystalline universe theory. It suggests that space-time itself is built a lot like a diamond. Its laws are stable not because some cosmic programmer wrote them that way, but because they're part of this incredibly robust geometric structure. Reality is held together by pure geometry.
Now, the first clue for this theory was, wow, it's just incredible. Physicists were sketching out these complex equations from string theory, and they found that the drawings looked identical to the error-correcting codes your web browser uses to keep from crashing. The first thought was, oh man, are we in a simulation? But maybe there's a simpler explanation. Maybe it's not software. It's just the natural geometry of the universe, literally proofreading itself.
So to find the exact geometry, researchers turned to an AI. They gave it one mission: find the single most stable geometric constant for our universe. And the answer it came back with was this: 139.54 degrees. This number, it turns out, describes a fundamental tension, a kind of strain in the geometry of space-time itself. And this is where that one number becomes so powerful. When you calculate the energy that's created by that single geometric twist, you get a split that almost perfectly matches what we see in our universe, the split between dark energy and matter. It explains our entire cosmic makeup with pure geometry, no new particles needed. Okay, on to our second suspect. This one asks a totally different question. What if the Big Bang wasn't really a beginning at all? What if it was an impact? This is called the ekpyrotic universe theory. It imagines our universe as a three-dimensional sheet, or a brain, that's just floating in a higher dimension. And about 13.8 billion years ago, it collided with another one. That incredible impact is what we call the Big Bang. Now, what's so compelling about this idea is that this one single event elegantly solves some of the biggest head-scratchers in cosmology. Dark energy? Oh, that's just the gravitational pull from that other universe. The fact that our universe is bizarrely perfectly flat? Well, the collision would have naturally ironed out all the curves. And why is gravity so weak compared to other forces? Because it's literally leaking between the two universes. All right, let's dig into our third and honestly most mind-bending suspect. What if this entire cosmic show, every star, every galaxy, all of it, is just one single quantum object? This idea comes from a very real concept in physics called the Wheeler-DeWitt equation, and it does something that sounds impossible. It treats the entire cosmos as one quantum particle. I mean, just think about that for a second. The exact same math that we use to describe one tiny little electron could, potentially, describe our entire reality. This idea totally flips how we think about the universe's expansion. We all know that standard balloon analogy, right? Where you draw dots on it, and as you blow it up, the space between them stretches.
Well, in this quantum view, it's more like a ripple spreading out in a pond. The universe isn't getting more stuff, its wave of probability is just spreading out, becoming more and more diffuse.
Okay, it is time for the cross-examination. We've got our 3 suspects lined up. Let's put them on trial and see how well their stories hold up to the actual evidence. So let's just break it down. Each of these theories has some seriously compelling evidence, but also a major hurdle. The crystal code's geometry beautifully predicts our universe's composition, but it has to explain why light isn't affected by that crystal structure. The cosmic collision knocks out 3 huge problems at once, but it needs higher dimensions that we can't see. And the particle paradox unifies the physics of the huge and the tiny, but it might not be testable, and it still struggles with dark energy. So, no, the case isn't closed, but the investigation itself, it's revealed something extraordinary. All of these clues, especially the ones from our first suspect, they're pointing toward this profound connection between the shape of the cosmos and, believe it or not, the shape of life itself. And this is where things take a truly stunning turn. The crystal theory predicts that the universe itself has a geometric handedness, a preferred direction, and we actually see a potential hint of this in ancient light, a tiny 0.35-degree twist. Now look at life on Earth. It shows the exact same kind of preference. All life uses exclusively right-handed DNA and left-handed amino acids. It's the same pattern. This suggests a possibility that is just breathtaking. What if the shape of life wasn't some random choice? What if the fundamental, asymmetrical geometry of space-time itself literally imprinted its structure onto the very first molecules, setting the template for all biology that would ever follow? And the rabbit hole goes even deeper, right into our own minds. Some physicists are now speculating that the same geometric principles that structure the entire universe might also be at work inside our own neurons, resonating with the cosmos, and maybe even giving rise to consciousness itself. And that leaves us with one final thought. Our investigation started with a simple cosmic bruise, but it's led us all the way to the geometry of life and even thought. It forces us to ask a really big question. Are we just observers separate from the universe and looking in? Or could it be that we're a direct product of its deepest structure? That we are the universe, finally becoming aware of itself?